Hey everybody, welcome to my talk on Falcor. My name is Jafri Hussain. I work at Netflix. Every user wants to believe that all the data out there in the cloud is sitting right there on the device. But what if you could code that way? What if we as developers could code like all that data was just sitting right there in memory? Before we go into how Falcor makes that work, let's talk a little bit about MVC, okay? So, a lot of MVC users out there, Angular developers know MVC, right? So how's MVC supposed to work, at least canonically, right? So the controller is responsible for grabbing data from the cloud, for the model that is, and then handing it off to the view. And then the view kind of acts like a black box. It takes that model and it outputs HTML. Right? That's what's supposed to happen. But the question I want to ask you guys today, and I know there's a lot of people out there using MVC, is does MVC really separate concerns? So, how many Netflix users we got out there? Yeah, quite a few. That's what I like to see. So Netflix, as you know, I think most of you, is a service that merchandises titles to you, allows you to watch things online. We give you a personalized list of recommendations, genres within them titles. And the way it kind of works is you select a title, and then you can drill down and look at the details about that title, like House of Cards, for example. And then you can also navigate to related titles. So if you were to sort of visualize the Netflix domain model, it would kind of be like one big graph out there on the cloud where you've got all these titles that are related to each other. Mad Men might be related to Breaking Bad, which might be related to Jim Jeffries, and so on and so forth. So let's take a look at what it would look like to apply MVC to the Netflix UI. So let's take that simple interaction we saw earlier about me selecting a title and then seeing details about that title. So I click on a title, and then we create a show detail controller and a show detail view. Now, the controller, if you're writing the controller, what you want to do as a developer is you want to be able to go and grab just the smallest amount of data you can from the cloud in order for the view to do its job, which is display information about that, right? Now, we've got a little bit of a problem, though, immediately, which is that how am I supposed to know, as the author of the controller, how much data to pull down about House of Cards? Right? Maybe the view is going to show the name of House of Cards. Maybe it's going to show its rating, but maybe it's also going to show the entire list of episodes or the entire list of shows, or the name of the 3 top most related titles to House of Cards. If I'm writing the controller, really don't know. There's only one way for me to know this, and that's to go look inside the view. Right? If I open up the view and I take a look, I can see that it's pulling down, well, these 4 fields. So I can either modify my query or the service that the controller is calling in order to pull just those 4 fields from my backend data source. So if that works, that's great. We pull down exactly the data we need, and then we render the view. So that's great, but what if we need to change the view? Right? What often happens at Netflix is a PM will come up to a developer and say, hey, look, we've got this great new original House of Cards. We want to highlight particularly the great cast. So let's add a field to the view that shows the cast of House of Cards. So what would we have to do in order to make this change as a developer? Well, the first thing I obviously have to do is I have to open up the view. And I have to add a new section of that view that's showing that field now. But I'm not done. If I was to just recompile this and push it, I would get an undefined there on my title, because I haven't changed my data load to also pull that additional field. So see up there, I've got to go change my controller or my service, depending on who's responsible for selecting those fields. So that will work, and we will get our data back, right? And we'll display it. But, I mean, aren't these things supposed to be decoupled? Isn't that the point of a design pattern? It's really to decouple pieces so they can change independently of each other. I suggest to you, if we use MVC in this way, our controller and our view are really implicitly coupled. And we know that because we can't just change one independent of the other. So it's worth asking the question, is MVC broken? Is it not really doing its job if it's not separating concerns? Well, we actually at Netflix think it's just misunderstood. And today we're going to talk to you about a Falcor framework that actually allows MVC to work the way we think it's supposed to work. So what is Falcor? Well, Falcor, at a high level, is a data access framework that lets you code like all the data out there in the cloud is sitting right on your device. Basically, you stop thinking about the network. Now, it's also as important, before I go into more detail about exactly what Falcor is, it's as important to tell you what Falcor is not. Falcor is not a replacement for your database, MVC framework, or your app server. If you're using Node and Mongo, that's great. If you're using SQL Server, that's great. We want to try and integrate with your existing stack. You shouldn't have to switch databases to use Falcor. So what Falcor does is it allows you to take all of your backend services, and Netflix, for example, has over 80 of them, and abstract them as a single JSON resource out there on the cloud. Then Falcor gives you tools to use on the browser in your Angular application, for example, to access that data as if it's all sitting locally. And then Falcor will go and dynamically load that data and give it to you. So you can allow you to code as if all that data is sitting right there in memory. So how does it do it? Well, Falcor is effectively an asynchronous model. That's really what it is. It's a model that when you query for data, it gives you back a promise, or in our case, an observable. So let's see what happens when the view requests data from an asynchronous model. So first we have all our data out there in the cloud. And Falcor allows us to take all that data, no matter how much it is, and expose it as one potentially huge JSON object out there on the server. But instead of downloading that entire JSON object, what happens is that we take what we call an asynchronous model, and we hand it to the view, and we let the view drive the data access. So instead of the view just looking up a property synchronously off a JSON object, it goes through an asynchronous interface to access all the properties it wants from the JSON object. Then the asynchronous model takes all the requests from the template, and it batches them into a single request to the server. Instead of downloading the entire JSON file, though, it uses the query string to pull down just those fields that the view has asked for. And so what we've done is we've shifted the relationship from the controller trying to choose what data to load for the view to letting the view actually decide what data we pull down from the server. So we get the data down, and then we hand it to the view, and the view renders itself after that asynchronous process of the model's asynchronous promise resolves. So then we click a movie detail page, and we go ahead and make a similar request. This time, once again, we use the query string to just pull exactly what this particular view has asked for from the model. Now it goes down, and we navigate to related titles, exact same thing all over again. We just pull the section of the model that the view has requested, exactly those fields. Now, well, the other service that the asynchronous model provides is that it caches any data that's retrieved from the server in memory. If you were to peer inside the asynchronous model, what you'd find is a JSON cache that looks just like a fragment of that JSON object out on the server. And so if they hit back, for example, and we see an identical query for the same information, that promise resolves immediately, and the view is rendered. Once again, hit back, get to the main screen, happens instantly. So Netflix on Falcor. My colleague, Michael Paulson, today is going to show you what it would like to actually build Netflix on Falcor. So I'm going to turn it over to him.
Thanks, Jeff. You can keep it. Cool. All right, hi. I'm a core contributor to Falcor, and I work with this guy, so it's okay. So Netflix on Falcor, what does that look like? Well, really, to do that, we need to kind of go through a few steps. Let's first start by just having a local domain model. And all we need to do is just mock that. And once we mock that, we need to take that local domain model and we need to move it. We need to move it into a Falcor model, a Falcor async model. And once we've done that, we're now working, instead of directly with the JSON, we're working indirectly with the Falcor async model. And once we do that, we can just take that model and move it to the server. And once it's on the server, we're now, from the browser, making a request. It could be local, it could be on the server. And once we do that, you will come kind of to a point where you don't want to keep all of that memory on a node server. You don't want to keep it on your server. Instead, you want to use your stateful stores, your databases, and grab that data. But how do we grab it? Well, the client makes a request. We have a specialized router object that will take that request and map it to the model's operations. Gets that data, then from the JSON the little JSON object brings it back, and we can put it into the cache. So let's do this. Let's do step one. We're going to mock the Netflix domain data. So what is Netflix domain data? Well, Netflix has a list of genres. What is a genre? Dramas, rom-coms, teenage paranormal romances, you name it. That is what genres are. From genres, we can actually grab a specific title. There's a list of titles with every genre. So let's kind of go through that. Let's look at that. All right, so here is our domain model. It looks just the same. For the sake of brevity, we only have 2 genre lists and 1 title per genre list. So if I were to access the name of the title of the first genre list, how would I do that? Well, I'd log out. Everyone can see it, good. Model.genre list, titles, name. And what do we expect to see? Well, we should expect to see Daredevil. So I refresh it, I see Daredevil. Perfect. So now that we've done that, we can go on to step 2, which is to take this and work with the data through the Falcor's async model. So let's jump back to our code. And so the first thing we're going to do is, instead of having just a JSON blob, we're going to create a new Falcor model. And we're going to pass the cache in through the constructor. So now we have an initialized cache. That's exactly what we were working with. And now, instead of working directly with the JSON, we're going to work indirectly with the Falcor model. So let's just delete the log, do a get value, and then since it emits a promise or an observable, we'll use the promise and just log that out. But we're not quite done yet. What we need to do is we need to have a correct way to query that data. So how do we get the data out of the model? Well, the API is, or the data is the API. I can take our previous JavaScript pass syntax, just put quotes around it, save it, and run it. And it just works. But, I mean, most of the time, at least when I'm working with data, I don't just grab one piece of data at a time. I like to grab a lot. So where JavaScript pass syntax breaks down, Falcor kind of makes it better. We allow ranges in indexers. And we also need to change this to get. So now we're not grabbing a single value, we're grabbing multiple values. So what does this look like? Well, it's going to look like something kind of out of a template. And so now we return genre list 0, titles 0, name, Daredevil, and the same thing for the second genre list, which is House of Cards. We also allow for multiple arguments into the get function, because a lot of times you're going to want to batch up several requests that could go out to the server. So let's just add one more. Ooh. And now we should expect to see rating. So we see rating. Excellent. But we don't always have to do it this way. We also provide multiple keys in indexers. And what does that mean? Well, instead of just having two separate strings, one for rating, one for name, we can just pass in rating and name into a single query. Same thing happens. So getting the data is kind of half the fun of applications. What about setting the data? So let's kind of go through an experiment here. We just got done watching House of Cards. It's a good show. So now it appears in our recently watched list. And now, since I really like the show, I'd like to set the rating to a 5. So I'm going to go down here and do a set and pass in the genre list. Genre list, oh no. Titles, rating. What was that? Oh yeah.
Typo, slight typo. These things happen in live code.
Genre list rating, and I'm going to put this to a 5. And since we're working with async interface, I'm just going to pass in our previous query so we can see it all. Excuse the formatting. And then finally, we just need to log that out. That should all work. Log it out. And now notice that House of Cards is rated to a 5, but something happened there. The second House of Cards is not rated to a 5. So, Joffer, could you explain what just happened here?
Yeah, for those who might have missed it, right, House of Cards actually appeared in 2 different lists because we just recently watched it, but it's also a new release. And Michael did something totally reasonable. He set rating of House of Cards in the first list to 5, but then he found that that other copy of House of Cards had a rating of 4 because we didn't modify that copy. So what happened? Well, we ended up with a stale cache. And this happens all the time with single-page web applications that need to keep an in-memory cache of data that they've retrieved from the server before. Now, typically, application servers, and Angular applications, for example, use JSON to send data from the server off to the client. And that's great, but Netflix's domain model is a graph, right? And pretty much every interesting domain model is a graph. The challenge is that JSON is for trees. JSON models information hierarchically. And so when we take our graph and we expand it into JSON in order to send it over the wire, what happens? Well, we end up with duplicates. So most applications use the duplicate and identify strategy. When a client asks for a section of a graph, and then that application server has to expand it into JSON in order to send it over the wire. So what does that mean? Well, we take House of Cards, which was one instance out there in a database somewhere, and we copy it. We make a copy of it, and then we add an identifier so that when that data gets down to the client can hopefully use that information to dedupe or at least figure out that when a change is made to one of these titles, it should be propagated to all the other titles. So when that data gets sent off to the cloud, what we're hoping is the client is going to be smart enough to dedupe it and basically make it the same object in memory. Now, in practice, this usually requires a little bit of code, and usually a handwritten code for your individual domain model or for all your individual messages. Unless you're writing handmade code to go over those messages, if they happen to have duplicates, you can run into this stale data problem. Well, but wouldn't it be better if we didn't have to make copies of that object at all? In fact, wouldn't it be better if we only ever had one copy of an object in memory at a certain time? Then when we made changes to that object, we never have to worry about propagating those changes to the other objects. To do that, Falcor introduces JSON Graph. JSON Graph is really just a convention for modeling graph in JSON objects. It's actually just a regular JSON object. It's just a convention we use. So every JSON Graph object can be stringified and parsed by existing JSON tools. So let's see how that works, and we'll go to step 3, and we're going to convert the domain model that we've written so far in JSON to a graph. So the first thing Michael's going to do is he's going to create one and only one location in this JSON object where we're going to store House of Cards. Now, we're going to put that in a pretty logical position. We're going to create a map of all the titles by their identifier, and we're going to put House of Cards at that map using its ID as the key. Now, we're only one step away from having a JSON Graph object. The only thing we have left to do is to go to every other example of House of Cards in the JSON object and replace it with what we call a reference. A reference is a new value type that JSON Graph introduces to JSON, and all a reference does is it points to a location in the document where that object, the only location of the document, where that object can be found. And so that's all that it takes to build a JSON Graph document. Now, what Michael's going to do is he's going to take the exact same code that he wrote before, and he's going to run it. This time, we're going to see that when we request data from a model that's in JSON Graph format, what we're going to get out is something that looks like JSON, doesn't look like JSON Graph. All of the objects have been copied. However, because we have only one instance of House of Cards in memory, when we do a set operation on it, it applies everywhere it appears in the graph. So now, we're going to, as I said, we've converted that domain data to JSON Graph. We're going to go to the next step, which is moving the data off box to the application server. I'll hand it back to Michael.
So one of our propositions we made earlier is that you can take, once you've mocked your data, put it into a Falcor's async model, you can just take that model and move it to the server. We shouldn't have to mangle our client code to consider, is this local or is this remote? So let's just go jump back to our client code, and we're going to just delete the model. And now I'm going to jump over to our server code. So I've intentionally made the server code in white example, so we can kind of distinguish, am I working on the client, am I working on the server? You guys don't have to try to read my editor and figure out where I'm at. Now I'm just going to paste that model in. Now that we've pasted that model in, we need just a little bit of glue to make this all work. And I'll explain that once I get it over here. So I'm going to require in Falcor, grab the model off of it, and since we're using Express, I'm going to take an Express endpoint, member/JSON, and every time it's called, I'm going to return that model. So we provide a little helper method so that it's very easy. Because when you do a get titles by ID, we need to know, okay, what are we calling? So this just helps you with that. So you just provide the model in which it needs to call. So there we go. We have our was once in memory on our browser, now on the server. So let's jump back to our browser. So what do we do here? Well, let's simplify this query and just simply do a get. And then we need to log this out. But we need to define our model. So what is our model? Well, instead of having a model with an initial cache, let's have a model with a source. You're probably asking, what is a source? Well, a source is a way for us to remote our operations we're performing on the model to whatever that source is. And in our case, since we're working on a browser, we're going to have an HTTP source. And we just need to specify where our server model can be found. And now that I've saved it, I should be able to just execute this query, and it should work. Now, most of the times you want to new up your models, and so I'll do that right here. And whenever you make changes to your server, you cannot forget to restart it. So now that we've done both those pitfalls and everything is working good, let's check out our network. Let's make sure I didn't do any hand tricks and lie to you guys. As you can see here, we actually called to the server with the paths I specified. Genre list, it looks a little bit different. It's not in the path syntax, it's an array syntax. Genre list from 0 up to 1, title 0, name and rating. So let's just do one more query right just live in the browser. And this time, I'm going to grab the box shots from the first title, and I'm going to log out that box shot. So it goes to the server, comes back, and we get the box shot. And let's look at the network. We have a second request, and what happened here? This is not the query I just put in. So I think Jaffer, why don't you explain what happened?
Yeah, so we saw earlier that he made a query, and then it got sent off in an HTTP request to the server and faithfully represented. Pretty much exactly what he asked for got sent to the server. But then Michael turned around and he asked for the box shot of the title after he'd already downloaded the name of that title. And we saw that actually the path that was sent off to the server looked totally different. In fact, the path that was sent off to the server had been optimized to retrieve that title by ID. So he was able to write code just the same way he would have coded against an in-memory JSON model, and automatically Falcor turned that into an ID-based query that you could use against the database to do a really fast lookup. When most of us work with endpoints, usually we have very different APIs when we deal with different endpoints. Some endpoints have paging APIs, some endpoints require you to pass IDs. With Falcor, you approach the object exactly as if it was an in-memory object, and over time, as it learns about your data model, it will suddenly begin to optimize your queries into using identifiers. And how does it do it? Well, it takes advantage of JSON Graph and the references that we introduced before. So let's say I want to do a get on this path down here against this JSON Graph, this little fragment of JSON Graph. Well, we just evaluate the keys just like we would if we were looking up an object in an in-memory JSON object. But as soon as we come to a reference, what happens is we take all of the paths, all of the keys in that path that we've evaluated thus far, and we cross them out and replace them with the reference that we found. And that's actually the path that we send off to the server. And that's how the ID optimization happens. It's completely transparent to you as a developer. Now, once the server processes that path, it can just take a look at that ID, look it up in the database really quickly, and then send us back just the fragment of the JSON Graph document we asked for. Then we take that, mix it into our local cache, and that's how Falcor works when it communicates with the server. So now we're going to work on the last step, and this is the full circle, where we've taken data all the way from the client in memory, we've moved it to an app server where we keep it in memory on the app server, and now we're going to take it out so we keep our app server completely stateless, and we're actually going to use a specialized Falcor router to retrieve any data that we ask for from the browser from our back-end data sources on demand. So instead of storing this in memory on the app server, we're going to keep our app server completely stateless, and whenever the browser asks for a path or multiple paths through the JSON document, we can go to any one of multiple data sources and create that fragment of the JSON object on demand.
All right. Just kind of one thing to look at here. Notice that on our client, we provided an HTTP source. This would remote operations from the browser to the server. Well, let's look at our server. We have another source. It's the router this time. We're taking in those same operations performed from the browser to the server and mapping them yet again to your data sources. So let's look at the Netflix data source. Or let's look at a route. So our route right here, we're just going to do a simplified route. We're going to grab just the name of each genre list. So in our route, we can specify, if you've used Express or pretty much any MVC framework, you should be pretty familiar with what routes are. So we take genre list ranges, which are just any set of numbers, and a name. And we're going to match that and pass that into this function. So a typical input would be genre list from 0 up to 1 and name. Now we need to craft the output. If you've ever worked with endpoint, this is pretty much half of what you do in endpoints. You get some sort of payload from a data source, you morph it into what you need it to be, you pass it down to the client. Exact same thing here. And we also have a genre list service that we're going to be pulling some data from. You pass it in a range and some cookie so it can personalize the results, and it hands back a list of titles or a list of rows with their index and their name. So let's just live code that out right now. So right away, I grab the IDs off of it. And why can I grab the IDs? Because in my route, I've named the ranges IDs. So you can name any of these little permutation objects. So let's go down. And we're going to return whatever comes out of our genre list service, which is a promise of the payload. So we're going to do a get for the range. And of course, since in our Netflix router we have the request object, we're going to just pass in the cookie. And then, from the payload, we're going to pass back that JSON graph response. So let's craft that. So this is kind of like how the boilerplate would look. So, the last thing we need to do now is actually just fill out this out object. So since our payload returns a map with a single key rows, which is an array, we'll just for each over all of them and just put them into the map. So payload rows. All right, so now we have finished our endpoint. This should properly build us the JSON graph response. And so since we've edited our endpoint once again, don't forget to restart the server. Let's go back to our client now. And since we've only built one endpoint, let's just grab the name. And we're going to log it out. We're going to jump back to our client, refresh it, and see nothing currently. Are we making responses here? JSON G. What did I do?
I think it's Jason. No, he's good.
Hold on. Live coding. No, JSON G is correct. We need to return a JSON graph envelope.
Yeah. So the JSON G indicates that we're returning a fragment of JSON graph.
Rows. Oh, I totally named that incorrectly. And, of course, restart your server. And there we go. All right, thanks, everybody. So we got 0's name, 1 name, when we get the data out from the router. And so, Joffer, why don't I hand it back to you?
Yeah, so I just want to take a moment to emphasize what just happened there. We started working against an in-memory JSON model. Then we started working against it indirectly through a Falcor model. Then we took the data right out of the web page, we moved it onto the application server, stored it in memory, and didn't change our client code at all. All the client code, the API for working against that model, stayed exactly the same. Then we just plugged in, used an HTTP data source to plug in a local client model to that data that we'd moved to the application server. And we saw that, well, we could query data from that in-memory JSON object on the application server. Finally, we took all the state out of the application server and used a router to match certain types of paths being requested from the browser and convert them into requests from the back-end service. So we could create all of that data, just that little fragment of data being asked from the browser on demand. So it doesn't matter what your back-end service is, you can use Falcor and this particular pattern to load your data. And this allows us to use a pattern that I like to call asynchronous MVC. Now, if you think about MVC, it's really made up of 3 parts, right? It's made up of the model, the view, and the controller. Now, the way the view and the controller communicate is with asynchrony, right? If you click a button, the view can asynchronously send a message off to the controller. Now, the controller and the model also communicate asynchronously, right? The controller can asynchronously load the data from the server, the model, for example, and then hand it to the view. But for some reason, historically, we've decided that the view and the model have to communicate synchronously. Most JavaScript templates depend on you having JSON in memory in order for them to render correctly. But most JavaScript template languages can't work against asynchronous data like promises. And it's that asymmetry of forcing the view and the model communication to be synchronous which causes the problem with MVC. Because the controller has to make sure to get all the data in advance so that when the view renders it with a template, it can render it synchronously. And that forces the controller to know things that really only the view should know. So by fixing that one last link in the chain, by allowing the view and the model to communicate asynchronously, we allow the view to actually drive the data access. All that data access code just disappears from your controllers. You can just modify the view, and then because the view is driving the data access and requesting asynchronously from the model, that will lead to, hopefully, a very efficient network request for just the things that the view requires from the server. So let's take a look at how this looks from 500 feet with asynchronous MVC. So back to our original example of when you click a title in Netflix and you see a House of Cards detail. So we create the show detail controller and the show detail view. We have the Falcor model, which makes it appear as though all the data out there in the graph is local. And first, the show detail controller, its job is now not to go and get the data for the view. Its job is simply to select the root node in the graph to pass to the view, basically telling the view, hey, use House of Cards as your route of accessing things through the graph. Now, when it does that, what it does is it actually creates another little asynchronous model bound to that one location in the document. Now, we render the template, and in this particular case, we can see that we're using Angular 2's support for asynchronous template binding. And this is actually something really exciting, because Angular 2's support for asynchronous template binding allows us to work against an asynchronous model with not much more difficulty than working against an in-memory JSON model, right? That's not a lot more code. We're just using the pipe async at the end there. It's equally declarative as when we're binding to an in-memory JSON object. So they've really taken most of the pain out of working against an asynchronous API, which is one of the reasons why we're excited about the potential of Falcor and Angular 2 working really well together. So then, this template might make 4 or 5 requests to that asynchronous model. But because the model is asynchronous, it can hang back, wait for all those requests to happen, and batch them into one efficient query to the server. And now, we're going to take advantage of the cache in the asynchronous model to optimize that query by ID. And so we send efficient ID-based queries for that information about the House of Cards title. Because we already have the reference for House of Cards. We downloaded it when it was displayed in the gallery. Then the data is sent back just exactly the data of the view requested, and we emit HTML. And that's how asynchronous MVC works. So Michael's actually going to show it to you in action now. We're going to show you that we can just modify the view and have the changes appear immediately, no controller code required.
All right. Turn on the microphone. So, last example we promise. And I can't cancel it. So, here is some Angular 2 right here, and let's pull up the website so you guys can see it. So we have this nice kind of view for all of our movies, and I can click on House of Cards and see that we have, you know, the description, the list of genres it's rating. So let's just edit this template. I'm going to grab some extra fields right out of the model. Let's just put starring in there. Exactly what we did before. The PM stops by my desk and asks, we need to highlight the cast. So I come back here, I edit just my view, and I'm able to grab just that information from the server and bring it back down.
So as we've demonstrated, you can edit your views directly and make very efficient back-end queries to select just the data required. Testing. Hey. Oops. Almost there. So today, Netflix uses Falcor for all of our UIs. All of the Netflix UIs are powered by Falcor. And we're planning to open source Falcor very soon. And we're also looking to open up and give early access to those willing to help out with integration with various MVC frameworks. At Netflix, we use Falcor with React, but you can use it with Angular 2 and any other MVC framework for that matter. So if you're out there willing to help us out with integration, we'd love to bring you into the fold. And if you want information on Falcor and you want to follow us, check out the Falcor.js Twitter handle, where we'll be announcing information and the open source dates. So we're hoping to open source very soon. Thanks very much, everybody.